Hello everyone, how are you all? Welcome back to the channel again. I hope all are good and learn something new with day by day, right? I hope all of you enjoy this journey with me, a learning journey. And whatever information I will share with you in a theory class, also in a practical like these study cases. Today we're talking about a study case, right? Whatever I taught you about the technical knowledge in a repairing field, right? It will benefit you, I hope, in your journey on your table also. So, talking about the theory and the practical class, the both videos come one by one, right? I have a less time, so there is a less videos, maybe a weekly one in the 10 days. But whatever I will share with you, it's important, crucial data, right? Now, today we discuss about another phone. This is a Samsung phone, Samsung 610F, J610F called J7 Prime. This one had a charging issue, right? I will show you. On the right side, on the top, there is a charging ampere meter, also the multimeter. Now, I am connecting the charger. Just I'm already open the phone. I will show you. This is a Samsung J7 Prime. So, I, I thought make a video on it. This is a new topic for you. So when we connect the charger, let's say it's taking ampere 1.4 ampere after the current goes down, right? And the logo appear. After the logo, in between there is a sign in a triangle. There is a thermometer meter, right? This is called a thermal error, right? I'm talking about the Samsung. This thermal error, each and every phone, you will whatever the phone, right? Whatever the company, every company had a thermal circuit. But we're talking about the Samsung because this phone had a Samsung. So talking about the Samsung, right? A Samsung company. Now, when you connect in a off condition, this type of the error will be appear like this. I will show you again, right? Now this error, right? Look at here on the right side, my display screen. That's why I'm looking on that side, right? Now this error belong belongs to the thermal error. We call a thermal error. When we connect a Samsung phone, this kind of the error in off condition, but at a time the battery is percentage is 0, but we try to turn on the phone, let's say. So what type of the error in turn on condition I will show you. So the phone turning on, right? A Samsung logo appear, right? So basically this is a thermal error, right? In the last video we learned component. This error also related to the component. I will show you. Now look at here. There is a low light, but your phone is temperature is too low. Charging will continue when the temperature returns to the normal. If you see the and the phone switch off because the battery is down. That's why phone is turned off. But if the battery charged, let's say suppose 1 to 2% or 3%, the charging logo appears like unplug the charger, disconnect the charger. Your phone battery is too low, too high. These kind of the errors. Now these kind of the errors comes through a thermal circuit, right? There is a we learn a resistance, right? In the last video, resistance has many types. One of the type called thermistor. Remember, right? That's why I'm always asking, learn properly, read properly, make notes. The one of type of the resistance is a thermistor, right? Now thermistor had two part. I mean to say two another variant called PTC and the NTC, right? A positive thermal coefficient and the negative thermal coefficient. Now the PTC and the NTC both resistance work. I mean to say used in a mobile phone. The PTC used in a mobile circuit, I mean to say mobile battery BMC circuit, right? In other companies like Oppo, Vivo, Realme, Redmi, right? These kind of the phones. But this kind of the error comes through a processor gives the error show on your screen. right? Now we connect the charger again and let me see this charger. Now it's taking 1.4, a proper ampere. After that, it's taking the ampere decrease and this error, these type of the error. CPU will be appear on the display, right? This is called thermal error. So I'm already made a video for the members, which I'm explaining in a deeply how the circuit work, each and every line, and how to tackle this kind of the problem, how to check all of these lines. So let me also show you some hints, right? How to tackle this kind of a problem. First of all, whenever a phone come to you in this condition, first try in off condition. After that, you will go to the turn on. Try to turn on your phone in a Samsung, and there is a another error, right? Unable to disconnect the charger. The battery temperature is too low. Your phone temperature is too low or too high. This is thermal related error. Now, thermal related error comes basically there is a circuit and the NTC resistance is stored. The NTC purpose whenever the heat increase, right? Whenever the heat increase, NTC resistance decreases value like 100k. Suppose the 100k resistance in a 35-degree, right? So when heat increases from a 38-degree, it will decreases the value. So 80-degree. I mean to say uh, 80k from 100k to 80k to 70k, right? So current will passes more through the circuit. It's uses on a divider circuit. Let me show you after we talk to this topic and we repair this one. So we go to the Borneo. Now I am open the Borneo and open Borneo in a G series G610F. Right now in schematics, open layout and schematics one by one. Now layout. Now open the schematics. Right now we type TH, right, and the next and zoom. Now you will see there is a some thermal circuit THM. It's a thermistor thermal circuit. AP thermal, bad thermal, application thermal, battery thermal. In Samsung, multiple thermal. As I already told you. Now there is a divider circuit. Now this thermal circuit work on a divider. Now this resistance is a open. Now this one, right? It does not use so and see. Now this resistance in a series, both resistance. Now this resistance in a 100k, a fixed value resistance. Now this is our NTC, right? A thermistor. This is also a 100k value, right? Now we zoom the. Now this is a symbol of the thermistor, right? Now these two resistance connecting in a series. Everybody know the divider circuit? Let me explain to you again. Now suppose in a series a 1.8 line comes, right? In series two resistance connected R1 is a 100k fixed value resistance. After that R2 called thermistor, it's also a 100k and connecting to the ground, and R2 is a thermistor. After that in between a line emerge and goes to the CPU called bad thermal. Through this line CPU sends the heating according to the voltage fluctuation, right? I will explain to you in a motherboard. So we go to the motherboard and let's check the voltage first. The circuit had a voltage and the divider circuit work or not. So we go to the first we will find the location, right? Where is the resistance? So this is our NTC resistance PH 4001 and this is our 4052. So copy this anyone and paste in layout and the next zoom zoom. Now near the mic, these two resistance, right? This is the mic and these are two resistance. So in a microscope, this is the motherboard. Now these two resistance, right? A black one and the gray one. This is was R1 of fixed value resistance and this one is our NTC. Look like a coil. Both shapes are different. I'm already deeply explain about the thermistor, right? For members only video, how to tackle this problem. So we check this first voltages. So we multimeter on a voltage mode and connecting a charger, right? Now we connect the charger and let me check. Now charging ampere starts and now voltage. Check the voltage and now R1 get 1.8 voltage. That means this resistance connecting to the power IC. Okay. Now the other side, or you can say NTC on the divider side. Now there is no voltage, maybe connectivity issue. Let me connect properly on this side. Right, 0.9. So divider circuit work, right? So why this problem comes? Why the CPU shows the thermistor error, thermal related error? Mm. So we remove this. I mean to say, open the motherboard and we will diagnose this. So separate the screen and open the motherboard. Now I'm tell you, I'm already made a video about for the members only about this section. How the thermistor work in a Samsung, how many type of the thermal circuits in a Samsung, and how to diagnose each and everything in a full detail, right? So the motherboard is open, right? Mhm. So if you want to join, then join. Now we diagnose this resistance. I mean to say, check the test the resistance one by one. Now first we test in a diode mode. After we test in a ohms mode, the resistance value. So and we diagnose where the problem comes. Right. So first of all, we in a diode mode. Right. Now we check one by one. Right. On a first side, on a R1 with the black probe on a reverse side. So there is a connectivity. That means this line connecting to the power IC and this side connecting to the CPU. Right. So both like these are okay. Now we check the ground. Now ground will also okay. Now we measure the resistance value in ohms mode, multimeter ohms mode, right? One by one. Now this resistance R1 is 99k, approximately 100k. According to the schematic, it's okay, right? Now other one, the R2 thermistor. Now this 27, 26, 25. So round about at 27, 28. I think there is a problem, right? So this resistance shows a less value, right? Something is abnormal, right? So now when you find on a YouTube, right, like for this solution, if you go to the YouTube for this solution, mostly YouTuber claim that if you remove this circuit R1 and R2 and the problem will be solved, right? So, but in my opinion, which resistance, I mean to say which engineer, right, made this circuit, right? I mean to say, made this design for the thermal circuit. It's working basically, right? So, how this will be bypassed? I mean to say, if you remove the circuit, how can this work? So, first we, right, engineer has a sense or knowledge. So, if you remove this, how can this work? So, we test on this. We remove both resistance according to the YouTubers. I mean to say, if this phone working or not, if we remove both resistance, right, working or not. First we check this, right? If this worked, let's say, but if on a for few hours or few minutes, it's not a permanent solution. Let me remove this and we test this if this will be work or not. Damn it. Hmm. So we remove this. So I will told you, whatever the engineer, I'm interested which engineer installed this circuit. There is a logic behind the circuit. So if you bypass, I mean to say remove the circuit, how can this CPU? No, I mean to say this will work. Right? My English is not good. I know. So let me clean this and check. Now both resistance are removed. Right? So let we check this will be work or not. So we pack this and connecting a charger. Let me pack. So some in YouTube there is a sometime there is a no solution, right? If you try to without a knowledge, only believe in a YouTube, right? There is no result. Sometimes you will harm the phone, right? Now we connect a charger. So ampere start and the zero point 0.4, the battery symbol appear, but there is no thermal error. It's no thermal error, but the ampere does not increase. 0.4. This is abnormal charging. It's like a fake charging. First, this is a thermal charger show, but now this is only a battery symbol. So it's convert one problem to another. Let me connect again charger, right? Again connecting a charger. Let me some changes. Now connecting a charger. So again a battery appears 0 0.4 current, right? No changes, no sign or thermistor. No ampere goes to down or increase anything. So basically, this will not work, this formula. Now, first problem convert to the another. First, there is thermistor problem. Now, there is a battery symbol stuck. Then we remove, when we remove this circuit. So let me try to on. Now, it's also not turning on. No 0% symbol, only a battery symbol. So this is not work in our case. Mostly it does not work. Basically, if you have the knowledge, you can resolve it in a proper solution. But if you do not know and jump on a YouTube videos 1 to 2 and 3, 4 solution by solution, so most of the time it's not work, right? You can in front of you in experiment we remove both resistance, right? But there will be no solution. There is no solution. Is stuck on a fake charging, right? Now we replace this resistance, right? And let me check the problem resolved or not. Remove the screen and open the motherboard. Now under microscope. Now okay, there both resistance are open, right? So it's phone now in a fake charging. Now we install our resistance, right? So from the scrap motherboard, let me check, right? So one of X value, other is a NTC resistance. So let me check on a scrap motherboard, right? Now on this motherboard, we will find some resistance in the scrap motherboard. Now this one, 10K, 4K, 15K, 16, 17, 10 kilo, 7 kilo, 8, 18 kilo, and 10 kilo ohm magnet. Now, हाँ जी भैया, N35 का कवर लेगा? नहीं सर। No. Now I'm changing both resistance with the fixed value resistance. Also NTC with the fixed value resistance because I have no NTC. I find in a many scrap boards, right? Now we find only a two resistance, right? So we replace with the two fixed value resistance with a different value. Basically, if you know the circuit, right? Wait a second, maybe a problem. Right now, our camera working. Now, basically, we will check this. Now it's working or not. After we will clear to you what will we have work on this. So we connect the phone, right? Now 0.4. I'm connecting charger 1.4 ampere, and the battery logo appears, right? And the charging continue before it goes to the zero. Now it's a 1.4 and the battery sign is available 0% and there is no sign of the thermal. Look at the ampere meter reading. It's working, right? 0. There is no sign of the thermistor, right? Before it will appear the thermal error. Charging connected and the ampere, right? Look at the right side on the top side, the ampere properly. Let me start the phone, right? Turn on the phone like 0%, but there is a no logo or thermistor logo, thermal error will be appear. Now we turn on the phone and the charging will be okay, right? So we try to wait for the 1% after we turn on the phone. So I'm changing the both resistance with the fixed value resistance because there is no NTC, right? Or if you know the circuit, divided circuit work, if both resistance is missing, suppose, and you know the output value, right? You can create it, the divided circuit from your experience. If you do not know the resistance value without the schematics also, you can work. So let me try to on, right? The battery is a 1%, right? The ampere in a 1.4 charging, right? So let me try to on. Now the Galaxy J7 Prime, the logo appears. So I will tell you, if you know the circuit, right, you can repair it from anyhow. Now there is a NTC must resistance, but I have no right now NTC. But before we deliver this phone, we replace with the NTC because I will show you the problems. Now look at the charging battery percentage. Now in front of you there is a no error. Now we disconnect the charger and let me connect again and it appear no no error and the full charge properly. So I will show you, right? So if you know the circuit, you will be clear the fault. Without knowledge, you can't, right? It's a camera related warning, right? Now look at this, the battery properly charged and the ampere also run properly. It's also a good ampere consumption. No slow charging or good ampere, right? The phone will be problem resolved. How? Even we do not have right value resistance, but we solve the fault. Even the output will be okay. But now let me show the battery. There is a charging sign like a 2% and 3%. The battery increasing because there is a good consumption, right? So as it, right, I'll let me show you in a microscope. Now look at this. I'm changing these two resistance. Let me show you these two resistance or fixed value resistance. Before there is a NTC, right? The thermistor, there is no thermistor, a fixed value resistance. But the problem is resolved. Now before we delivering the customer, we can replace with the thermistor. So if you know the circuit, then you can repair it, right? So